Welcome back. In week 3, we explored how your code becomes machine instructions and how memory works under the hood. Today, in session 2, we'll dive into how your programs talk to users, reading input, writing output, and how to make decisions with conditionals in C#. This is week 3, session 2, input and output and conditionals in C#. Today we'll learn how to prompt the user, read their responses, display information, and make our code branch based on those responses. Let's get started. Why user interaction matters. In real-world programs, we need two-way communication. The user provides input, like typing a PIN at an ATM or numbers into a calculator, and the program responds with output, such as a balance display or calculation result. Learning these basics is essential to build any interactive application. We start with console readline, which pauses execution until the user presses enter and then returns whatever they typed as text. Use console.write to prompt on the same line, and console.writeline if you want to move to the next line after the prompt. Remember, readline always returns a string even if you type numbers. If the user types 25, it's still text, not a number. You cannot assign that directly to a numeric variable. To convert text into the correct data type, you use parsing methods int.parse, convert.toInt32, or the safer int.tryparse. Each behaves differently on invalid input. Tryparse is the ideal choice for user input. You pass the input string and an out parameter. It returns true if the conversion succeeds or false if it fails, without throwing an exception. This allows you to detect bad input and prompt the user again, preventing your program from crashing. No exceptions, just a true-false result. You can wrap this in a loop to keep prompting until you get valid input. When displaying information, you have three main tools. Console.writeline prints text and moves to a new line. Console.write prints text but stays on the same line, perfect for prompts. Console clear erases the screen when you want to start fresh. You can also embed tabs with HT or line breaks with HN and use string interpolation to combine text and variables cleanly. To let your program decide what to do, use the if-else structure. You compare values with operators like greater than, less than, equal to, or not equal to. The code in the first true branch executes. If none match, the final else block runs. This is how you direct flow based on user input. Conditions are evaluated top to bottom, and only the first true branch runs. When you need to handle many discrete options, a switch statement can be clearer than a long if-else chain. You read the user's choice, then use case labels to match exact values, with a default for any unmatched input. Each case ends with break to prevent fall-through. Use if-else when you need ranges or complex logic. Use switch when you test a single value against many exact possibilities. Switch shines when comparing a single variable against multiple exact values, especially with enums or char string. For a few branches, the performance is similar, but switch scales better when options grow and keeps your code more readable. From a maintenance standpoint, switch statements keep your code more organized when options grow beyond 3 or 4 cases. Here's a quick menu: deposit, withdraw, or check balance. You read the user's numeric choice, parse it to an integer, then use switch to call the appropriate method. Each method handles its own input and output, keeping your code modular and easy to extend. To write robust code, always validate input. Assume users will make mistakes. Use tryparse instead of parse to avoid crashes. Use clear variable names, e.g. user choice not X. Limit nesting. Break complex logic into helper methods. Avoid deep nesting by breaking complex logic into well-named methods. Handle the default case. Never leave a switch without a default. Test edge cases, negative numbers, empty strings, and unexpected characters. In your lab, you'll build a BMI calculator that prompts the user for weight in kilograms and height in meters. Uses a loop with tryparse to ensure both inputs are positive numbers. Calculates BMI equal weight over height times height. Uses if-else to classify BMI underweight, less than 18.5, normal 18.5 to 24.9, overweight 25 to 29.9, obese greater or equal than 30. Displays the result with 1 decimal place and a friendly message. This exercise ties together everything we've covered: I/O, parsing, loops, and conditionals. In this complete example, we prompt repeatedly until the user enters a valid positive weight and height. We use a while loop around try-parse calls to enforce positive numbers, then calculate BMI. Notice how the validation loop and safe parsing protect against bad input. Next, we classify the numeric result with a series of if-else statements: underweight for BMI below 18.5, normal between 18.5 and 24.9, overweight up to 29.9, and obese above that. We also display friendly messages for each category, demonstrating clear branching and user feedback. This example illustrates several professional techniques, input validation loops that keep prompting until the input is valid, string formatting to show BMI with one decimal place, comprehensive conditional coverage of all BMI ranges, user-friendly output including helpful advice. Common questions: why not use parse? Because it throws exceptions on bad input, making your code less robust. Can you nest switches inside ifs? Yes, but avoid deep nesting. Extract to methods instead. What about handling non-numeric menu choices? Use console, read key, and switch on keychar. Next time we'll explore loops for while and do while so you can repeat actions and process lists of data. Use notString.isNull or whitespace input to catch empty or blank entries. When debugging conditions, print variable values before each branch. Vapor small single-purpose methods, e.g., getPositive double prompt, to reduce duplication. Keep your console UI consistent. Clear prompts, spacing, and instructions improve user experience. That brings us to the end of Session 2, Input and Output and Conditionals. You now know how to interact with users and direct your program's flow based on their input. In our next lecture, we'll explore control flow in depth, starting with loops, so you can repeat actions and process collections of data. See you there.